Today I need to work on this truck, specifically the derrick bed, the post setter bed. I want to go through all of the function on this thing and see what works, what doesn't work, and come to a decision on what I want to do with this truck, because it's a nice low mileage truck. It runs good, it drives good, it's got a lot of great features. I don't know if we should fix this truck, make sure everything works, because there is a problem with the boom. If we should fix that boom and then sell it the way it is, or if I should just yank this stuff off of it and build this truck into something far more profitable, because currently this truck is worth X amount of dollars, but if I take that bed off and sell it and I put something else on, the value of the actual truck itself comes up. Now it has to be able to come up past the amount that I have to pay to do this and what I get out of that bed. So before I make any decisions, I want to get through this thing, get all the operations working, and see exactly what it is and if it's something we need to consider, or if we're going to take the bed off, build it, turn it into something that we know will make a good amount of money. This thing's heavy. I just ran it across the scales. It weighs 26,580 pounds. It is a heavy truck, and that's with no gear and no tools. Unreal. Let's get it started up. Let's get through some of the functions and show you what works, what doesn't work, and see if we can get it figured out. Come to a decision by the time we're done with this video. Well, we know the seat needs some attention, but I have another seat, so that's not a big deal. Door panel's a little worn. This part's broke like all of them. All these GM panels do the same thing. Now, I just got back from getting this thing weighed, so it's nice and warm and all that kind of stuff. So we're going to turn the PTO on. There we go, idled up. Our brakes are set, and now we're going to get the operations moving on the bed. Before we do anything, we want to get the outriggers set. Get them out so it stabilizes the truck. Because I'm not a derrick truck operator, I don't know where all of this stuff is. I wonder if it's down there. Tilt, up, down, lift. Oof, that looks like it's up, down. What that is. It must be a speed, maybe? Okay, I see this pulls out and swings. Let's see if we can find the outriggers. I thought I found the outriggers valving out here, I think. Is it? I would say. Oh, okay. I see. It goes out and down at the same time. It's one lever that does it all. Okay. Takes care of that side. Do we have a lever for this side? Is this it? Apparently so. Oh yeah. I don't really want to unload the suspension. Bring that back down a little bit. Starts to pull. Must be for the winch. Oh, there's a winch on the bed too, and a winch on the boom. All right, we got a lot to figure out here. Winch control, throttle. Oh. Okay. All right. Let's see what we can do here. I have no idea what this control's for. Oh. Something's running. Oh, it's a spool. It's up there. Okay. Oh, this one's the auger. So these are for the derrick auger. Okay, so we know that. And this is tilt. Oh, that's out there. That's the grapple. It's tilting the grapple. Up and down. Looks like I need a helper. Open and close the claw. Yep, we need a helper so you guys can see better.
Okay, so the grapple's moving. That's good. Claws are moving, or whatever those are called. Okay, the winch is turning, that's good. I can see something, I saw something turning back there too. Okay, that extends.
Up and down. There's something wrong.
In case you didn't hear, he said there's something wrong with the up and down.
Yeah. This is up. I got no action up. Look, watch. It's trying to pull it down. And it's trying to push the bed. But nothing will happen going up. So we got to figure out what's going on here. Idle up right there. Idle down right here. That's kind of... Alright, so we don't have... Doesn't do anything on our block spinning around. Yeah, it's got no settle there. So you can turn it spin around. Get used to it. Apparently you run the move now. You just run it here. There's a lever here for up and down. I'm assuming that's like heat control for those controls. I don't know. But we have a winch up here. The winch.
I can see that part that's coming through the wall there. I saw it turn, but not the wheel yet. But there's a lot of cable on there.
Oh, it starts now.
Yeah. That's a lot of cable on there. Yeah. I wonder if it's kind of bound up. It looks like it's rubbing against that one bar there.
I don't know if there's two separate winches. That's the one on the end of the boom. Go look at, because there's two winch controls here. There's this control and this control. This is that winch you were seeing nothing happening. This one,
it's like the rope
detach.
One or whatever.
Yeah, maybe. Go see.
Okay.
Go look at that winch inside. All right, go ahead. Go. here, we got 2 gears with nothing. There's a chain up here. Then there's a chain here. That chain here must move this back and forth. That's probably what that was. I don't know. Because that should have fed that cable left and right. Hang on. Hey, pull that winch brake up. Yeah, that.
It is up. Down.
Pull it down then. Now use that thing. There we go. Nope. Dang it. Other way. Yeah, I'm not sure about this. Oh, maybe this has something to do with it. Have a broken gear? Where's that supposed to be? Hold up. Well, I don't know what that's supposed to be or what it's supposed to do. If there's another gear supposed to be on here, maybe you guys know. Why doesn't this winch work? It's obviously not a very powerful winch. There's the specs on it. Let me do a little more investigating on this. There's a cover here. Where would that cover have been? I mean, if it went from here to here, what does that do? I think it just turns it from this direction to this direction. So does it go here to here and then what? Should be a chain here to here and then move this back. That ain't moved in forever. There's the one that runs that. Let's check the engage and free spool. I think I saw a switch out here. There's a switch out here for engage and free spool of the winch. Engaged, free spool. Let's see what that does. Go. Other way. Nope, still nothing. Try it now. Same thing. Other way. I don't know. Alright, hold up. Something's not right. I don't know what the deal is. I guess we'll look into that too. We gotta figure out why this is not moving. Ooh, these are electric. Alright, let me get a test light up there. So I traced these hoses out and they come up here to this block. And this block has got valves in here that are controlled by electric coils, solenoids, and when you add electricity, that magnetic coil in there pulls one way and it pulls a plunger. Well, I don't think you have to be too bright to see that that's obviously not going to work. So the way this works, you see this one's a ground and this one's probably power. We need to see if we're getting power to this now or if there's a short somewhere or if it's just this coil. So we're going to put a test light on here and see what we can find. I'm using this one because that function seems to work okay. Lady, you're gonna have to come up here and hit the power. Okay, well, that's down, which is up, which is kind of weird. And then let's see what we got here. I got nothing, but I don't know if I have a good ground either. Go the other way. Oh, nope, stop.
I did.
Let's see if I can find a better ground here. Well, the coil will not come off. It's rusted on there pretty good. So I'm going to see if I can locate a valve and a coil both. That way, I got it loose. It's loose in the block. That way, if this doesn't work, I can just replace it both. It's pretty rough anyways. This one is a momentary valve, and that controls the auger lock. So that's why this one doesn't have power all the time. But regardless, I'm going to see what I can find on that valve right there. Well, I brought it over and put it in the vise, and I was able to get the nut off, but the coil itself just disintegrated. So now I'm trying to drive the valve out from the center of the coil by letting it sit on the jaws right here, and so far so good. Well, I can get the numbers if we need it. Boy, that is so rusty. I'm going to clean that up on the wire wheel a little bit, but that's how the coil came apart. That thing is so cooked. I don't know if it's just from age or being left on. I really don't know, but it is in pretty bad condition. Thankfully, I was able to get the numbers off of the coil and sent them over to our friend CE, who is the hydraulics guru, knows all hydraulics, and he told me we could find a number on the base of this. If we can, he can order me a new one. So I'm going to get numbers and give him a ring and see what he's got. So CE doesn't have the parts, and this is not a press fit. It is screwed in there. So he told me I could take this apart. Ooh, he said don't lose the pieces. I think I'll get this over on the bench here. Open. Ooh, that is stuck. I need 2 hands for this. Man, it is stuck up in there. That moves side to side somehow. That's interesting. If it turns a little bit and comes out. Oh, there it goes. Piece of crap right there. And come on. I saw you in there, little guy. There it is. Okay. There we go. There's the bore. Looks clean. We'll hose that out real good. Make sure there's not a piece of junk in there. Then we'll inspect this. But this was sitting in there. That's the piston. And there's some crud on the side of the piston. Wonder why it was stuck. So we're correct. It definitely has to overcome the spring. I'm not a big Band-Aid person, but that's that fingernail that is about... I smashed that finger, and right about the time that the pressure started to go away, I hit it with a punch up with an air hammer, and I'm afraid I'm going to lose that nail. It's coming loose and it's keep getting caught on everything. I'm usually not a Band-Aid person, but it's kind of necessary this time, I guess. What we got in this bore? Well, looks pretty clean too. I wonder why it was stuck. Let's see. Yeah, it doesn't want to come out of there. Wonder if there's damage inside that bore. Something's not right, huh? Well, let me get it cleaned up and let's see what's going on. Well, I have cleaned this up, and for whatever reason, this does not want to go on that board and move back and forth easily. So it's possible that something happened in here, and there was a shock against this with hydraulic pressure and damaged this bore where it's no longer true. Because if you have hydraulic pressure sitting on this valve and waiting to come through here, and there's a sudden jolt of a large amount of pressure, like maybe something fell or whatever the case, it can literally force the hydraulic pressure up in here and swell this, or it can swell this tube or deform it in some way that the piston won't go in and out of it. And I hate to put it in there too far because it gets stuck, but if I put the actual valve control in here, making sure it's very clean, then you can see it gets stuck. Yeah, it gets... That thing should move back and forth in there easily. So something's wrong in that bore. I did see there was some marks on the piston. So, yeah, right there is where I saw it. Let's see if I can show that to you. This is before I just tried to put it in. I saw these marks right there on that piston. So anyways, the coil that sits on top of here literally is pulling on this, and it has to overcome this little spring here, that little bit of spring, and that's what we were trying to work against right here, to push on it with the drill bit, and it wouldn't move. So rather than mess around, I think I'm just going to go ahead and get a new valve, because something is not right. Well, I just heard back from CE, and I asked him, I said, hey, could this be from maybe a shock load, or maybe they dropped something and it made that boom come down, you know, real hard and deformed this bore? And he goes, dude, it's probably from your favorite thing you always talk about. And I'm like, duh. Sometimes, man, professionals will make a inexperienced guy feel really, really dumb. I just got done telling you I had to beat this coil off because it was so tight on there. What do you think's inside there? That's right, a steel sleeve. And what's steel do when it's over top of there and it gets water in there? That's right, it rusts. When it rusts, it starts to compress on that bore and makes it so tight that it deforms the bore. When it deforms the bore, it's no longer perfectly round. The perfectly round piston can't slide up and down it easily. It is nice to have friends who are very good at what they do and remind you of how dumb you really are. Anyway, so we do need a valve. We need a valve, we need a coil. So we'll get these two things coming. CE doesn't have it. I wish they did, because I prefer to spend money with him at where he works, especially since he helps me out all the time. And he's a good friend of ours. You want to see your friends do well and obviously stay employed. He doesn't have one, so I'll see if he wants to order it or if he wants me to find one or what we're going to do. But when we get some parts, we'll put this back together. The weather sure changed quickly, but we got our valve and our coil for the Z8500, so we're going to change these out real quick and see if we can get this thing to work. I found the valve online. It was pretty reasonable, so was the coil. I think there's like $100 here. It wasn't much money. It's a good sign.
Yeah. It's very windy today. We got a snowstorm coming. So.
Now I gotta redo some stuff. I gotta redo some wiring. This ring terminal goes on the back.
No way for me to get up there to really show what you're doing, but there's really no way for me to get up there to show what you're doing, so I'll just try and do it from here.
Alright, now this is the original power wire. It goes on this, and we got to make a jumper to go from there to ground, so let me get something to make that real quick. Well, that should work. Well, it's on. It's on enough to try. Let's see what happens. Let's fire this thing up.
blowing my phone. Jeez. What?
There's another coil right here,
Yeah.
and it's tied in somewhere, but I don't know where.
Okay.
I don't know if there's a switch here.
Oh, I see what you're saying.
But there's something that controls the coil and sends power beyond, but it's not working. So I don't know where this wiring goes. I think that's flume right here and goes under. I don't know, but if I manually override that,
That's how you got it to work? Oh, okay.
so this is a solenoid that I was talking about. I'm manually overriding it by pushing it in because it's actually stopping flow right now. But you see there's two wires that come into this coil, and it's probably some type of safety, I'm guessing. I don't have a wiring diagram or a hydraulic diagram to see what this is, but I assume that's a safety. And it's tied into the first operation, meaning lifting the boom, so that if you don't have, maybe the outriggers are out or whatever it is, it won't let you lift it until all that's done. And a lot of times those are in series, so that both of them have to be down and the switch has to be closed before it'll do that. It'll send power or ground, in most cases probably controlling the ground, but regardless, we'll see if we can find a diagram, whatever, and go from there. See, I was thinking this is pushing against something, like there's a spring in here that's pushing against a switch right somewhere in this area, like a ground, but I don't think it is. Oh. Well, let me finish this. I didn't see the light come on that said the outriggers were out. Well, looky there. There's a switch. That looks to be the same type of wire that goes up there. I bet you that switch, that's our outrigger deal, where it's supposed to let it know that they're out. And being though it's broken, we may not have that switch, so I wonder if that's what's going on. I'm gonna have to clean this off and see what we got here. How long that thing's been soaked. Alright, so here you go. It's got a switch in here. That switch was out. Wonder if it's just not making contact anymore because it's been corroded up for so long. Man, look at that. So more than likely, there's one of these on each outrigger, and they're in series, I would imagine. This was probably welded somewhere so that when it came in, it would close up, and when it went out, yeah, look at that. I don't know where it's supposed to be, but hear that putter, and that's the air compressor going in bypass. Yeah. go look on the dash and see if that outrigger light comes on. It's on the right hand side. I think it might be red, orange, green, something. It says outrigger out.
The only thing I seen lit up is PTO, it says.
Okay.
Unless I'm not looking in the right place, but I think I am.
Okay, so this is probably our problem. This switch here is supposed to tell you that the outriggers are out. And I don't know if the switch is no good here, but see this type of wire, it's like a cable. I have to see where that goes. That might be an input to that box behind the cab. I don't know. But it's a round wire. We're going to have to trace it. It comes up the center there. What a mess.
There's your towel.
Yeah, not my clothes. There's one on this one right here. So that's got to be what it is, and if the other one's not hooked up, you would think it would be saying out. But if it's not, if the switch is hooked in, that could be a problem. So what I'm going to do is see if that coil is got energized now, and it's magnetizing and pulling or whatever, or if it's off right now. Seems like it's not doing anything. So if that's the case, I could probably put 12 volts to this coil right here, and then it work like it should, if the theory is correct. It's not creating any magnetivity here, nothing at all.
Is it really a big deal to just push that in?
Well, it's not right. It's a safety, because if your outriggers aren't touching and you go to move this, you could roll the thing over and hurt yourself or somebody else.
Well, I'm guessing that's been
like that for a long time.
Yeah, and they just used that.
And being though this station will not move, it was supposed to be able to swivel over here and latch in over there, and you could stand on that stand right there, that step, and operate. That's what it was supposed to be. I still don't know what this is. It says lift up and down. I don't know what that's supposed to be, because it doesn't do anything.
I don't know.
I thought it was like move the controls from one place to another, but it just says lift up and down. So I took the plug off that coil, and it's a 3-terminal coil, which leads me to believe it puts power one way of the coil and pulls it one way. Power the other side maybe pulls the other way. I'm guessing that's why you would have a 3-terminal. And I have power one way. One way I've got 13.8. The other way we have nothing. So it makes me wonder if I reverse these two terminals. Yeah, I've got nothing across the two either. There's one that has a common. There's two whites on here, which leads me to believe this is going to be, either our power or our ground. The other side is the opposite of what it takes to make that work. I don't have a good place to ground it. through. Okay, so this is a positive here on the outer, so that's supposed to be positive maybe. So maybe it takes that positive away from this one and moves it to that one. I wonder if I got any jumper leads.
I don't think so.
Maybe I got some wire. Let's see if I can,
I'm sure you got wire.
see if I can find some wire. I don't know if you can see that, but that's a symbol on that terminal for ground. That's what that's supposed to mean. So we are correct in our wiring. It just doesn't do anything. We got power. Maybe I should just make sure that it's not, make sure it is or is not making negativity. Nothing. Nothing. No spark whatsoever on any coil. Nothing. That coil's not working. I think we're just going to take this home and take it apart and look at it, since we're going to be waiting on parts anyways. We'll just put it in the vise and take the valve apart and see what's what inside there. If nothing else, we'll get a little education. Right?
I guess so.
So I got the valve apart here. I want to make sure there was nothing sticking in here, even though we didn't have any coil that was working. And I've been flying blind here on how this system works because I couldn't get in touch with anybody from Terex to get a diagram. But I finally, after being on hold forever, got this schematic. This schematic shows that we have two outriggers here, just like the truck actually has. We have 12 volt DC coming in on a master switch that comes through these two, which are daisy chains. So you see it comes in like this, and this one has to close to send power here, and the other one has to close to send power up to the coil, and the other side of the coil is grounded. The man I spoke with at Terex said that this, even though it has that ground terminal on it, that symbol for ground, he always thought those were for alignment, so that you couldn't, once you've wired this connector, you couldn't accidentally put it on backwards and reverse the polarity, because when you reverse the polarity of this coil, it will pull the other way. That's what he thought it was for. He could not explain why we have two wires on this. So what I was thinking was the actual ground, and the possibility that it was doing reverse polarity or something was not correct at all, because we have no continuity between here and here. Now, I don't remember what the spec was. 7 ohms, I think, is what you're supposed to have here and here. Let's see what we got. Hard to do one-handed here. Do that. And that. Uh-oh. Oh, boy. Alright, changed over to alligator clip. Oh, dipstick. Let's zero us out here. We got 2 ohms right now. We'll zero that. What do we got now? 7 ohms. So we are right on. So if we actually put power and ground here, we might have a working coil. I don't want to get ahead of ourselves, but we knew we had 13.6 here, and we had ground here. This has a ground on this terminal. We had nothing on this side. I was thinking that it was going to be here to here, which obviously it's not. So let's go get us a battery and put positive on, I believe, this side, ground on this side, and see if we get any pull. I got my jump box set up here, and we got the negative coming down. I'm using a white wire on this side. Vice grips are just here to hold it from moving it around. This is our positive coming off the other terminal, and a lot of guys will say that this jump box doesn't work well, or it's a problem or whatever, and I find most of the time they don't understand how to use it, and that's the problem. Okay, so we're using as a constant 12 volt source. We want to see that piston right there move. And it is moving. it is working. Okay, so what that tells us is the valve has the ability to work, the coil has the ability to work. We just have to understand why is it not working. And if you go back to our schematic, we have key on power coming through this side of that switch that's on the outriggers. There's two of them, and they're what's called daisy chained or series, meaning it has to have a complete path through each switch in order for this to enable that valve, that solenoid, to energize, move that valve, and allow that boom to come off its perch. So normally what this is NC is normally closed, NO is normally open. Okay, so what's happening here is you're using a normally closed all the way through here. So when the outriggers are stowed, these are normally closed, meaning you have voltage going through here. When the key is on, this is pulled, and we push on it, and we can operate the boom. So with the absence of electric here, we should be able to operate this thing because it's going to open this. That's a theory. What I don't understand is how this solenoid, you see this is a power side coming through these two, and then there's a negative side, that's all there is to it. Then why does it not operate with the coil off of it? Why do we still have to push in on this to make it work? That makes me wonder. All right, so I'm going to interrupt here because this just isn't making sense what they have here versus what we have in real life. So in order to understand this, how this is supposed to work or how we think it should work, you have to understand the system. So this is our circuit that we're working with. The way it happens, the way it's plumbed, is we have a reservoir tank here. This is a hydraulic symbol for a tank. The tank has a suction line to the pump. The pump sucks the fluid from the tank, creates pressure, sends it to the unit selector valve, which is the handles that we use to direct hydraulic pressure flow. Out of there, comes up to here, and is going to go to the unit. In this circuit, that right there is a T. There's a T in the unit, which comes over with a hose to our valve block that has that valve and electric coil assembly on it. One side comes into here, the other side of that block, that hose, goes back to the reservoir. So what we're doing is, because this valve is a normally open valve, means that when there's no electric applied to this thing, the fluid, instead of it building pressure here and actually moving something, is going through the valve and returning to the reservoir, the tank. We don't have to return all the fluid, we just have to prevent it from creating pressure, because hydraulics is that. It's the hydraulic pressure, the fluid pushing against something to move it. That's how it's going to work. The bigger the surface area we push on, the more we can lift, the more we can move. So in this case, it's normally open, so it returns in the rest position. This is a bigger, broader system overview where we have the same thing. The pump sends it up to a block, into our valving. That block goes up to the unit. We have our valving here, which this is our line that would go up to the lift of that boom, and it's teed off. This is our unit solenoid, normally open. NO means normally open. As long as it's open, it's returning pressure and fluid on this line, which goes back to the tank. Now, that makes perfect sense to me. Where it becomes a little gray, like I'm not quite catching it, like I'm missing something, is in the electrical part, which is really kind of odd. So this is going to have a safety setup, these safety switches that are going to prevent somebody from being able to lift that boom before the outriggers are put out. I assume that's how they're trying to do this. They want to make it so you cannot lift it off its perch until those outriggers are out, which makes perfect sense, because if you've ever ran one of these, anything with a boom, you get to turning, you get out too far, you can flip that thing over in a hurry. So here's what we have for safety. We have a 12-volt circuit, a 12-volt line going through a fuse. That's a electrical symbol for a fuse, through a master switch, which in our case is the PTO switch in the cab. And then it comes down here, there's a junction here, and then it goes to our outrigger switches. There's 2 outriggers, 2 switches. And the way the system works is, in order for this to work, we have to be able to have everything working as it should. This is where it gets a little weird, because in this situation we have a normally closed switch on each outrigger, meaning that in the rest position we have contact from this terminal to this terminal, and from this terminal to this terminal. So when this one closes, 12 volts flows to this one. When it closes, 12 volts flow from it and flow up to that solenoid, which has a ground, and activates that solenoid. And because this is a normally open solenoid, when the coil is acted upon it, it closes that solenoid. So when we close that solenoid, remember in here we had our flow coming back to reservoir. If we close that solenoid, now we can build pressure. Now we can stop it from bleeding out, and we can start building pressure, and the boom can move. So here's where the problem lies. If you saw in the video, we know it's a normally open valve because when we reversed the polarity, we tried to suck the valve in and make it open more, it moved very, very little. When we tried to go the other way using the coil, reverse polarity, it moved quite a bit more to close the valve. It just doesn't make sense to me. In this situation, they're saying that when the outriggers are stowed away, that we have 12 volts to this solenoid, which contradicts what this diagram is designed to do, because we would be closing that. So if the outriggers are in, we would be able to operate the boom, lift it, and do all the functions with them stowed. That's not the way it should be. I have to think this, normally closed, was meant to be a normally opened insignia, abbreviations here. Because the way it is right now, as soon as they're out, the way they have it written here, this would open. That means that in the event that you would have a break here, or one of these are broken, this doesn't work, or this doesn't work, the line is broken, the connection's bad, or the coil is just completely gone. If this was accurate, you could operate that thing with the safety features serve no purpose. So I have to think this is a mistake here in this writing. So I'm wondering if this part here is inaccurate. Now, as far as the outriggers indicator light are concerned, it doesn't work either. I didn't look into it, but just to go over the system, ignition key on, it turns power at all. That's off the ignition, not the master. So as soon as you turn that key on, if your outriggers are out, what will happen is the power comes in here for the ignition across this contact to a normally open contact. So then when the outriggers are out, it closes that contact if either one of those is out. This is a flaw as well, because this should not be like this in series. This should be in parallel. Because if one outrigger is out and the other one is not, it will not turn the light on. If one outrigger is out, the other one has to be out. Otherwise, your path is not complete. So I don't put a lot of merit in their wiring schematic here. This is a relay. So the way this light works, that 12 volt ignition source is coming into this switch, coming into this switch. And it comes out of here over to the relay. This is a relay with a coil winder in it. And we know what coil windings do. Coil windings pull, they create magnetic force to pull something, a contact. So we have power coming in here, we have ground coming in here. So when all of the moons and stars are aligned, we have a straight path through here. It activates this coil, which this coil is showing right now in the rest position, which is weird too, because this should be drawn with 30 to 87 right now as being open, because that's open. This is showing 30 to 87A as being closed, because that being a pull. Regardless, that's not a big deal. You'll figure that out. So on terminal 30, we have 12 volt ignition coming in. This is only for that light. So when this is energized, it pulls down here, makes the contact, sends it through here, and turns the light on. See those lights, those lines on the outside mean the light is on, and then this is ground. So we have power coming in on this side of the light, and then on this side of the light, this is our ground wire telling us it's on. So I had to stop and clarify this because for a big company like this, on one drawing, there's a lot of mistakes already. Which, if I caught this, I don't know what all could be wrong on this. But anyways, I wanted to clarify that because things were not adding up for me as I'm editing the video. And I wanted to clarify it. I knew what I thought in my head. I just didn't explain it. So let's go on. You'll see what we found out. If you reverse the polarity on a solenoid, the coil, the magnetic force changes. So let's see what we get. You see it's pushing it. I'm going to turn it on. Okay, now it's pushing. Now this way it's pushing this. We want to make sure it's right because as you can see, if we reverse the polarity on this, this thing will time out. Hold the output and we'll put this on here. And if you look, let's see if we can get that. You see it pushes. So we got to make sure that this is the ground side, this is the power side. That's what we got to make sure of. So we're taking away the power is what should be happening. All right, let's get over there and let's see what we can find out, see what we can figure out. Yeah, something's not right here because this terminal right here is what has the ground. This has power on it, and this one has nothing. And apparently this is not supposed to be used for anything. So I don't know if someone's been in here trying to make this work and rewire it. I mean, these wires are original, but maybe their location in here was not. Because according to our diagram, it's supposed to be this one and this one. We shouldn't have anything on this at all. So I don't really know what to think of that. We do have a ground on this one, but we... Oh, lost a screw. Don't want to do that. But we do not have a ground on this side. So either we have a broken wire here or a bad ground. I don't know. So after digging some more, it looks like someone has had that apart, and what was going on, what is believed, is that there is 2 wires coming in to power this, and there's 2 coming out taking power to another switch, and that's why there was double. So someone was probably trying to get this to work and apparently made a mistake, maybe. I don't really know, but I'm gonna try and get this back together and give it a shot and see what it does. I didn't bring a screwdriver small enough for that little guy, so I have to use old trusty here. I need 2 hands. Alright, we are back in. Now, let's see what happens here. This is our up. Yahtzee! Now we're working. Now she's working right. And smooth too. Very nice. Alright. I'll tell you, I think I'm fixed. You gotta hold, takes 2 hands, because you gotta have this pulled back and push this button, I think, to release the auger, because that's what seems to happen every time I try it. As far as I can tell, everything's working like it's supposed to now. auger out. Well, that is fantastic. Everything works that needs to work. I don't really care about the deck winch. It's not really a big deal. Wasn't that kind of cool? These are all quick disconnects, so you could take this tilt head off and put the basket on if you wanted to. Not a very big hydraulic motor back here. Wish I could find some specs on this thing, see if it was worthwhile for anything. Of course, it's got a rope on it, not an actual cable, so I don't know. 600 pounds. Maybe, I don't know. Oh, there's a shackle up in there. I'm kidding. Look at that. Got a shackle up in there. Okay, well, I guess we're doing pretty well. Everything works. Pretty happy about that. What is this? So this is a pinned on attachment for the auger on the boom. That's interesting. So you can take that off. No kidding. Huh. Alright then. So it could just be a basket boom or something, maybe. I don't know. I'm just pleased as punch that we got the old girl working. Let's get it stowed away. We have got every function on this thing working now, so that's pretty cool. We can verify everything. And I think the total cost was like $100 to make this thing work. That ain't so bad. Now keep in mind, the outrigger switches broke over here, so that needs repaired. And this one over here, I think, is not quite right either. But regardless, we do know the functions work. I don't think you could put it to work as a post setter derrick truck as it is. You'd have to have some stuff done, but regardless, at least we know the functions are able to work. Not too bad at all. I don't know what we're going to do with this truck. I bought it because I thought it was a smoking deal. There's lots of opportunities here to do a lot of different things. We're 10 foot from the back of the cab to the center of this axle, and 15 foot 6 to the end of the frame, and it is double framed all the way to the back. You can see right here, that in there is a double frame. So I have some ideas what I'd like to do with it, but if I was younger and faster and all that, I would take that pedestal and that boom off, and I'd use that sucker on a small rotator wrecker, you know, something little. That boom's rated at 16,000 pounds. I think that angle's pretty steep though at that weight, but regardless, it could be used for a lot of different things. Like for us right now, it'd be good for lifting stuff and moving it around this yard. It's pretty valuable right there. I wouldn't mind taking that auger off. I think I can get pretty good money out of that auger with the post hole auger motor and bit itself. Pretty good value there. But anyways, leave in the comments, what do you think we ought to do with it? Make a great, well, a lot of different things, I guess. But anyways, I'm cold. My hands are freezing. I'm glad it's done. I'm going back to the shop. I got some other things to work on, so I'll catch you guys in the next one. Thanks for watching.